Great. Hi all. Good evening. Welcome to one more episode of Wednesday Hangout of B.NET. If you are regular, you know about the Wednesday Hangout from B.NET. For the others, this is an initiative from B.NET, the Bangalore.NET user group, where we get speakers who speak about a developer-related topic on every Wednesday at 9 p.m. Indian Standard Time. Today we have Abhishek Narain. He works with Microsoft India as a technology evangelist, where he helps developers adapt to the latest Microsoft technologies. Today is going to speak about the Windows Phone application performance consideration. Without much delay, over to you, Abhishek.
Hey, thanks a lot, Karthik. So I hope you guys can see the screen.
Yeah, we can see the screen.
Great. So at any point of time, just let me know if there are any Q&As. We'll try and take it up as it comes. And I really don't have much PPT, so we'll just go into the talking mode and the demo mode and look into the code. So the idea of this talk is building a much more responsive user experience on a Windows Phone device, and I'm focused more on the Silverlight based app development on Windows Phone. So we all know now that there's something in the Windows Phone 8.1 from the runtime side, and we can use those APIs, and we have a pretty nice tools in which we can figure out where the memory leak is happening, how much of each of my XAML elements is taking how much of memory. All those kind of things is available over there because it's inherited from Windows 8. So whatever diagnostics we had on Windows 8, 8.1 is there for Windows 8.1 runtime apps as well. But most of us, as I see when I talk to customers, as you know about me, I work as a technical evangelist here at Microsoft. So we do talk to customers a lot more often, and all these top apps, the top 50 apps, top 100 apps, top 200 apps is something which we really work very closely with the partners. And what I'm going to share today is mostly those insights which we generally find working, in the lights of, apps like Book My Show, Naukri. All these are pretty much branded apps. They are Indian apps and very branded apps, but they might not be using the apps, or while developing they might not be considering performance as the main thing, because it's not a game. It's a very simple XAML driven app. It's nothing direct 3D in it, and nothing from the DirectX world. And so people might think that performance will never be an issue over there. So looking at those things, I'm just going to talk about a few things which I generally see going wrong in most of the apps. As developers, we don't really care about those kind of things. So that's the idea, intent. And we'll also use a lot of diagnostic tools to actually figure out what's going wrong, where is it going wrong, and so on. So with this, let me just get started. What I'm going to do is open up my Visual Studio. Wherever required, I'll have a notepad here. Let me just minimize this. Let me come back to the Visual Studio. So what I'm using here is Visual Studio 2013 Ultimate. You can use 2012 as well if you are developing for Windows Phone 8, Silverlight apps. If you're developing for Windows 8.1, even the Silverlight apps there, you can still use, you probably would have to use 2013. This is 2013 over here. And I have quite some interesting demos here, basically to test out graphics when I'm using XAML. I'll talk about that. So to give you a high-level overview, what things I'm going to talk about is, firstly, we'll start with the tools. What are the tools which we should, as developers, use it to get to know our apps? How responsive is it? Rather than publishing the app and then people start rating it really bad. And we read the reviews and then we kind of redo the app or push in an update. So that's not the right way to go. Visual Studio gives us beautiful tools which with we can actually get into where my app is going slow or fast, or how is it performance wise. We can do complete profiling of the app, so we're going to talk about that. Then we're going to talk about the major things in an app which you use, like images, the media, how you work with a lot of XAMLs on a single page, then how you go about the user inputs, maybe using the progress bars for lengthy operations, and how to go about displaying a list, what control would be ideal for that. We'll also do a very good comparison of a panorama versus pivot, when to use what, because sounds interesting. Panorama, very specific to Windows Phone. Everyone does love to use that, but imagine a panorama having a background image, a bulky one, and then it having multiple items which are doing async, so service calls to load the data into it. Maybe if it has 20 or 30 different items loading up data in it, those kind of scenarios is not very suitable for Panorama. Panorama is meant for beauty. It's meant for fluid navigation, but it's not meant for scrolling 50 items down the list on each of those pans and having 5 pans or 6 pans, or maybe 3 or 4 is ideal number of pans in a panorama, nothing beyond it. So we now also call that as hub template, right? So keep those things in mind when you're using panorama. Use pivot. In terms of performance, I would say when you are using huge amount of data and it's not locally available data, it's something which you're getting through a service, REST-based API calls, do go ahead and use pivots in there. The initialization of the controls happens when you can do it per pivot, and it kind of works very efficiently versus the panorama where everything gets initialized right at the beginning, each of those items. So even though the data load will be happening in the background, but the controls get initialized for all the panoramas or right at the first instance. So which does bring me to the point, like if I have a lot of custom controls and stuff on my page and a lot of items in it, panorama actually gave me performance issues in few of the apps which I was doing, and we actually had to fall into some of these measurements of performance tuning, which I'll talk about today. Like we kind of decoupled the whole app. We create multiple assemblies for the app so that we can load those when required, and at the same time we created a pivot and a panorama, because we still wanted to have a very rich UI using panorama. So we split that whole panorama thingy into panorama, which later on click of a particular item inside that panorama, inside a pan, took us to another pivot. So it's not like putting pivot inside panorama, but taking into another control and loading that control and disposing this control and so on. So that kind of helped in maintaining a great performance in that app, because that app required data entry, which means I go ahead, see all my details here, nice looking stuff here, but once I log in and I want to edit my stuff as well, like it's like a profile page, and if you were to do something like create a Facebook profile, and this is something related to jobs search, so you give your whole CV out there, and if you want to give the whole CV input through a panorama, that's criminal. So we had to bring in a pivot which showed your CV. Once you click on that, on a summary data, it took you to pivot with multiple pivots of maybe your current profile, your past profile, each of them being separate pivots, and nicely loaded up data. Also gave you enough to read on that part of the screen, rather than making things complex. So probably I can't demo that code as well because it's not yet on the store, but probably later on, once probably I'll do a blog or case study, and then we can refer to that and have a session on that. So not that one right now. So that's regarding that. So let's get started with the tools now. So here's one example. Basically, it's a more graphic intensive stuff, just to check out some values here from the debugger, or the tool which we have over here. So a couple of things before I get started. We all know from Windows Phone 7 days, there's things like frame rate counters in emulator, which we can use for Windows Phone 8 application, like how performant it is, what's the frame count, how many frames are getting painted every second, and so on. So those kind of things. The thing which I'm primarily going to use to diagnose everything I do use is Windows Phone App Analysis for Windows Phone 8. That's the tool which I'm going to use. And one more thing, before you test your apps, something which you should know is, before releasing your app, testing it on a real device is what is really recommended, even by Microsoft. And practically, even I would suggest you to actually test it on a lowest end device, the device which maximum people will have to test that app. So test that app on an actual device and not using an emulator. I'll give you a reason for that. So when you build your app in a Visual Studio environment, the code is not actually compiled into a native image, how it actually gets installed later on the Windows Phone, but it gets into a machine independent common intermediate language, something like the binary file, which was earlier known as MSIL. So we call that SCIL. And this CIL is what you submit to the store when you are ready to sell your applications. People download it. That the thing which you upload there on the store is exactly the CIL. So at that time, the binary file is converted from CIL to optimized machine dependent intermediate language, or MDIL. So this is what we actually need test on: optimized machine dependent intermediate language. The MDIL is what gets installed on the devices. So finally, when users downloads your application to a device, the MDIL file is linked to produce the native image on that phone which he downloads this app on. And these steps are repeated in your application development environment whenever you deploy your app to Windows Phone 8 device. So the functionality of your app is actually not affected by this conversion to native code. However, native image typically starts and runs faster. So once you have the native image which gets installed on the device, that will give a different feel of how the emulators run this application on. And that this is the reason why everyone would say that you should probably test it on a native optimized environment, which is basically how app would get deployed from a store and it'll run. So the performance is going to be different. In fact, the performance is going to be, I would say, better over there because it's optimized for that device. It's a native thing. Whereas most of the times, what mistake we do is we run in a debug mode, and certainly when there is a debugger and when you are running in debugging mode, it's certainly not optimized code. It's meant for debugging. You need to have those watch lists and whatnot. So it's not certainly going to be optimized version of code running over there because you want to debug the code. So certainly the footprint of the code or the performance of the code is going to be a little slightly slower than when you actually release that build. So to test your app on an optimized image, you can select here very simply in the drop down as device, connect your device, dev unlock it, and then you can actually, if you just want to check for performance and nothing related to debug, you can actually do this as release, and then go ahead. Under your debug, there are shortcut keys for this as well, which is Alt plus F1, start Windows Phone application analysis, right? I can click on this. This lets me basically, if I were to just run this native optimized image, I would just click on device and without debugging, I'll just do run this without debugging, control F5, and it'll just go and start the deploy it on a Windows Phone, and then I can go ahead and use it exactly the way how it would feel when it comes from the store. Right? If you start with debugging, certainly if you wish to debug your application in between to figure out the issue in the code, then that makes sense. But if you just want to see how it performs on a Windows Phone device coming from the store, start without debugging and do it on a real device. This is how you do it, and you can check for all the performance manually. Now, manually is not going to be a very, very fruitful thing to get all these results. So you can also, if you want to deploy and debug your app on device by using debugging as well, but you still want to use an optimized image, you can still do that. By default, Visual Studio doesn't do that. So for that, you need to make a little bit of changes here. Go into Tools, Options, and let's go into debugging section here. Under the debugging section, a couple of checkboxes which you need to uncheck to make sure you run it as an optimized image. By default, it's not going to be as an optimized image because you're running a debugger and you probably want to debug stuff. The program or to the code should not rather be optimized here. So here are the different options. So under this, you will have find suppress JIT optimization module load option. So you don't want uh, basically to suppress that. So you will have to figure it out where that thing is. So one of these things is enable just my code. So clear this box as well, and then go ahead and make the change for suppress. Here it is, suppress JIT optimization on module load managed only. So uncheck this as well. Click on OK. This is how it would actually, even while debugging it, run it as an optimized image. So here were these two things which you need to keep in mind while actually testing your application in the final stage. Well, I'm not saying debugging it when you're trying to figure out a bug in your code, but when actually you are trying to get the performance testing and stuff done. So this is when you actually use it. Now, second thing is using a tool, because you can have a good look and feel and test it on a device, but you probably would want to use a tool to perform these analysis on your device and give you feedback on that, and then also be able to figure out the issues there. So here's the tool for that, and this is how I started. You can go into the debug option here, and under that you have start Windows Phone application analysis. You have Alt F1 as a shortcut key. Press that, you'll come to this particular page. Now you can do either monitoring of your application, which is recommended by Visual Studio to start with, and later on you can actually dig deeper into profiling. You can do complete memory profiling. If you want to actually check out details about each of those elements, how much of memory does it take, you have different controls, how much memory is each of them consuming, and all those details frame by frame. You can check memory option here for profiling, and you can do execution if you want to do some performance based analysis, things like how long does a visual tree take to refresh, and those kind of things frame by frame. You can check out execution as well. So let's start with app analysis here, which it suggests. And one thing which you need to keep in mind here, this is what I'm talking about, Windows Phone 8 or Windows Phone 8.1 Silverlight. So it's going to ask me for an emulator which has Windows Phone 8 on it. So I'm just going to run it there. Okay, and this is a small interesting piece of code. What it does is so you can see what it does. It when I clicked on add, it added a visual element, and it's having a storyboard, so it's animating that. I have an option of hiding this item, showing this item, changing, maybe adding another one. Go ahead, keep adding things. You can see I can keep adding stuff, and my frame counters and stuff is now actually becoming slow. So there might be my visual tree is actually growing a lot further here. So I can try out adding more and more stuff here, which actually doesn't help, but yes. So now let's enough of it. Let's end the session, and let's see what actually the performance analysis tells me out here. So it does copying log file to the desktop, parses the log file, what it and does analysis, and then provides me with a nice looking report. So the longer you do, the longer time this takes to parse and then analyze and then show you the report. Okay, I think it's done now. Cool. So this is how probably, I mean, this was a good case app. I'll show you some bad cases app as well while testing it. So it absolutely had nothing much in it. It was not doing any service calls, or it was not doing any internally calculation. The only thing it was doing on the graphics front, but apart from that, really didn't do anything. It didn't had uploading the data, downloading the data, nothing in here. So nothing on those aspects. So basically this report will give you these statistics to start with before you get deeper into it, like the startup time of your app, the responsiveness of your app. So by responsiveness, basically, it's a very misnomer. It's like a misnomer. So if you think your app is responsive in terms, you know, responsive here basically means your app is responsive to user inputs, one of those things. Secondly, how this guy determines your app is responsive is by checking out the CPU. If it's available, some compute time is available still after loading your application, or if your app is taking 90% of the CPU, it's going to tell your app is not responsive because you leave very less for UI input output thread to actually make the app more responsive. So it kind of depends on a lot of things. One of these things is how much of CPU is actually your application requiring. If it is very intensive, in that case, responsiveness will show in red over here, which will be a sad thing for your application. So you need to work on these things. This is how actually I worked on one of those apps, which showed me a bad responsiveness when it was loading this panorama. It had so many elements on that panorama that all the time I started with a startup time of like 7.5 seconds, brought it down to 2.5 seconds, the startup time itself. But still the responsiveness was something very difficult to deal with, because I could use all the beautiful things like the opacity, the visibility property of XAML, a lot of things, but at the end of the day, once I log in or something, those elements again reappear, and there were a lot of redrawing of the controls which was happening, so which kind of caused a lot of performance issues. And so later on we discovered, okay, the good thing to do is add page transitions. Page transition is a very nice way of transitioning into another page, as well as when there is a bulky page, generally you might need 0.5 of a second over there. So page transition kind of saves saves you from creating a bad user experience, or showing a slow transition to another page, or less responsiveness. It kind of helps the user feels your app is still responsive, even though actually it might not be. But since the transition is there, smooth and nice and fluid, it kind of works out well over there. So here's the other things here. Average memory used and so on. So you can see average memory used was 11 MB, max memory used was 19 MB. Another cool thing which I thought I'd mention is 8.1 had some changes in how the applications sit on the memory. So there's no allocation like 150 MB, 180 MB, or which earlier used to be in Windows Phone 8, is now taken care of. So you can allocate. Dynamic allocation is available on Windows Phone 8.1, which makes it switching between apps much faster as well. So thought of just mentioning that. But let's go into details about this report. Certainly, there are no performance patterns identified under the current selection. So basically, it will show you a map here, or rather chart here, and you can actually go down and see all those stuff: frame rate, CPU usage, app responsiveness, battery consumption, memory usage. And certainly you will see the battery consumption started going a little higher when I started adding more and more items. So with my CPU usage, so probably you can see, let me scroll slowly from left to right. So this is how it started in the 0th second, and each of these color codes have different values. For instance, the thing in green which you see is basically the UI thread. The purple one which you see is basically the application thread, and the gray things, I'm not sure if over the broadcast it looks the same, but when you try on a Visual Studio, you'll get to know. The gray items in the chart basically are the system thread, and things in the white is of course the idle thread. So the more the white, it's the better it is, unless your app is completely unresponsive and it's all white. But apart from that, having white is a good thing here, with a mix of others. But if you have more of purple, or if you have more of green having in the picture, in those cases be aware that your app responsiveness automatically becomes pretty bad over there. So once you can see on the timelines going above 10-12 seconds, when I started adding like 15 of those rectangles, and all of them were animated, so you can see now the purple, which is the application thread. So basically the difference between a UI thread and app thread, if you of course would be aware of, but in case if you're not, so the optimum UI thread usage, we suggest you to keep it less than 50% at any point of time. And screen updates, or touch inputs, those kind of things comes under there as well, for the UI thread. The application thread is basically anything else which is not the UI thread. Anything basically a background thread, or which does some calculations, you can always put in under application thread rather than keeping in the UI thread. So again, performance optimizations, if you have certain initialization methods which are having a lot of bulky code in it, you might want to put them on from there, because if you're doing an initialize, it'll take its own time, run, and then only the control becomes active, and then people can be be responsive to that app can be responsive to people. So you might want to think about having small initializations as well for these controls. The bulkier it becomes, the more time it takes to load and stuff. So anyways, on this chart, if I were to observe a particular pattern or an area, I can just nicely do this, and it'll show me for that particular selected zone start time and end time, and then observation summary. So if I expand this a little and go and read it, it tells me texture memory dominant, and native memory allocations are dominating the working set. Consider running the profiler with memory option enabled. Of course, this tells me that you need to run a profiler with memory options to be sure exactly what is taking what amount of memory to get into a deeper step. Apart from that, moderate CPU usage by system threads. So system threads, something certainly nothing to do with your applications, but when I'm running this on an emulator, it might mean like I might, you see multiple number of windows open within my system itself, so that might cause some issues with the CPU. CPU usage showing as system threads over there. So otherwise, on a phone, if you have a lot of background tasks running, it might also show you that your moderate or high CPU usage by system threads. But don't worry, it's nothing to do with your applications, not your fault at all. If the user has a 512 MB device, and if he chooses to run many background tasks itself, in that case probably yes, it'll always show up here, over here. So it does tell me that system and other apps are using 21.75% of the CPU. This CPU usage may be caused by other tasks that are running on the system, or they may be caused by system operations that are triggered by a user app. So ensure that no other tasks running on the system during profiling. Cool. So now that's what they suggest, is to switch off or not run those apps when you're running a profiling, to be sure 100% your results are very, very accurate. Okay. Now you can see the frame rates, CPU usage, you can see app responsiveness, it's pretty responsive till now. You can see battery drain though going a little above, and then you can see the storyboards, image loads. If you had loading of images happening within your application, it would appear here, and the garbage collection events, which happens if it happens. So you can see all these items, you can select, you can see all these storyboard items which occurs, and the time, the duration of each of those storyboards which happens, and if they are CPU bound or not. So you can get all those information right from here. So next step is, maybe once I've selected a particular region, I would want to get maybe a little deeper into that. So I would want to see my, what all elements. So now under performance warnings, I can select CPU usage or frames. So when I select on CPU usage, it gives me more details about what exactly is using CPU in this particular time snapshot. So it tells me the thread ID of that, tells me CPU time it uses. It's currently user thread, UI thread. Frame operations and other tasks are using the CPU time. You can see some values in the percentage over there. Nothing really alarming here, so I'm just not going to look into it. And then you can actually go inside a frame, and you can check out the CPU usage per item inside a frame as well, or functions called tree. That's very interesting visualization actually. So now once you are inside this, you can actually go inside and check out some inside a particular method name. You can see Microsoft phone controls, phone application, frame measure override, MS internal. So certainly there are a lot of native functions being referred to here, but you can basically get a good tree of all the function calls, and then check out the details like let me just make this screen bigger, like the inclusive times, each of those module names, and you can see they're sampling exclusive percentage samples, inclusive percentage samples, and those details here. But more interesting thing was getting into the frames. So as you know, I told you that those textures or things are nothing but rectangles, right? So if I have 150 rectangles on the screen, it'll each of those the frames, the start time when it started to get rendered, and then duration of that frame, CPU time, percentage, GPU time, the fill rate, all those things are available over here. So in fact, if you just hover over each items, it'll tell you the details. It specifies the total number of GPU textures used to compose this particular frame. So it used two. Most of them have used two. The higher it is, the alarming it gets. So that's how probably you can go deeper inside it. So in this sample, actually, I had no performance issues, so I shouldn't be cribbing about that. But let me see if I can get some performance issues in some application. That'll be cool. Yeah, so this is fine. This fill rate test is fine. It's gonna pass this. Let me get into a different one. Let me have a callback. Yeah, this might be a little more fruitful to test. Let me put this on to Windows 8 emulator. Debug, start analysis. I think app analysis is good to start with. So it does start. Now it gives me multiple options, like it already has an animated rectangle or a square which is moving, and on top of that it has options of caching as well. Basically how the caching here works is if you have you know a lot of XAML elements. So I'm talking about such scenarios which requires actually animations, a lot of animations, or visualizations using XAML. So in those cases, cache option actually works out pretty good. And how it works is basically it kind of rather than re-rendering that XAML per frame, it kind of creates you can choose to create a bitmap out of it, and it kind of renders it as an image, which is much faster, and it uses that caching out there. So if you have non-moving visualizations in the background, a lot of them you can use caching enabled for them. And in case you're redrawing it, certainly it's going to be an overload hit on that CPU at that point of time. But yeah, so let me just go ahead and add some items here. So I can go ahead and keep adding these rectangles, which are again animated, and you can see 14 of them added. Caching is on. If I switch off caching by clicking on it, my performance certainly is going to go a little bit on toss. So that's what I'm going to test it for. Let me add a few more items here. Make this as bad as possible. Now caching is off. Let me redraw this. Cool. So now I think I should now switch on caching. So I think I should get more fruitful results now. Let me check out the results for this app from this analysis of this particular app. So what basically you need to do is run this tool across all your apps, do all the use case scenarios, run through all the use case scenarios on an actual device, and get through this same set of results which I'm getting here using this tool. And rest assured that your app is going to get good ratings if you actually, as a user, get do all use case testing on an actual device using such a nice analysis tool. Cool. So in the meantime, when it till it comes back, we'll talk about some other things as well, and some of the common performance issues, like which might include improving animation performance or things like that. So you see now this time responsiveness, app responsiveness becomes poor at certain point of time, and probably we'll want to discover that when at what point of time. Max memory usage went high than before, and the average memory usage certainly again. So let's go into the alert phase of it. And very low frame rate. It bound to be happen, when I was in 106th second. This was in time, very low, caused by GPU bottleneck in the mid timeline. Select the time range for more details. So let me check this out, where my issues actually happened. So what you would see is, as I said, green is the UI thread, right? Purple is the application thread. But if I make sure, the reason behind that green is not there at the end, towards the end, I don't have any green, even though my app was running. The reason behind that is the caching, which came into picture. So it certainly helped me out here, the caching over here, right? You can see all these are input gestures, which gets captured in the timeline. So whenever there was a tap, something, so after this tap, basically, so you can guess that this tap, actually it shows you system Windows controls button, cache button, right? So when I clicked on that cache button, it started caching, my XAML as a bitmap, and started showing that every frame, and it kind of decreased a lot of XAML parsing, which otherwise had to be undergone during that storyboarding. And so you can see the UI thread kind of gets less loaded now. It's all the background thread which does my calculation in the storyboarding. But apart from that, it kind of gets solved. And also the frame rates become much better, as in the, it's not so intensive in that case. And if I look down, nothing significant here for that. So my memory usage was kind of consistent, kind of grew. Battery consumption got added as I added more number of rectangles. Okay, so CPU usage is, when it started, you can see it started to add more and more green items the more I started adding each of those items when I switched off my cache. So I think this is where I pressed my cache button and it actually stopped caching these, and you can see those green items happening over there. So certainly the responsiveness kind of went for a toss here. If I select this particular range, it'll tell me in that particular range, what's the particular issue which you are facing in terms of responsiveness and so on. And if I select maybe a range, and in that performance warning, I can go inside of frames. Inside those frames, I can check out cache updates. Yep. Oh, so there's no update for this cache. Well, it doesn't show me any data, but I can check out the element types. You can check out all those rectangles, the different shapes, the number of times the updates happened in that particular time period, total number of time it required to draw them, and so on. So visually, you can actually check out the animation speed. You can check out how bad is that animation making your app perform, and so on. All those details can actually be looked into it using this. So what my suggestion is to go ahead, use this tool a lot more in detail, and generate more meaningful reports, and do a detailed analysis of them, and certainly you will be able to figure out a lot of performance issues within your app and then fix that as well. Apart from these, some of those best practices, basically what I figured out to not miss while building an app is what I'm going to show you. So one example which I have is basically splitting apps across DLLs. So you can do things like, we have a lot of concepts. So if you're doing initialization on a particular control like Panorama, and then it's going to load the whole or initialize the whole Panorama at once, and you can't afford to make that Panorama really big. If you can split into something else, that is just pretty good. So you can have a separate reference to a DLL where you will pick up those XAMLs on need basis. So you don't need to compile them at once or initialize them at once, one go. You can do it as per the need comes. So in this example, basically it opens up a particular XAML, and it lets you use the navigation service to navigate to a different project, and which also has external page.xaml and external page 2.xaml. So basically you see there's a segregation, differentiation between them, so it's not part of the same thing. The idea being key, we want to have better performance. So if you can split your app into these smaller items, and then DLLs, and you can reuse them within your app, nothing as good as it in terms of performance. Certainly you get a good performance benefit. So in this example, when I run this, of course, as an end user, I don't get to know anything. It gives me a nice option, navigate via code, that is my C# file, or via XAML. So I can use navigation from XAML or through my C# code, where the need may be, and I can go to external page, or I had external page 2 as well. So via navigation, I'm going to go to external page 2. So this is how you can navigate into a completely different or split across DLL, and make a performance of the app better. In this, it is just an empty page. Give me a quick second. Cool. So it wasn't an issue, but trust me, if I were to do that same kind of heavy XAML initialization across, page one, external page two, and rather if I had that on the same panorama control as pan 1, pan 2, pan 3, my application would have been dead if I did that kind of a mistake. So splitting it across smaller DLLs does work. That this was one of those things. And another very important thing, so let me actually note it down. So I actually don't have a PPT for that. So letting I would say app resources, so I have even my image or a video file or whatever it may be, a content thing, application stuff in a separate assembly as well, which I can refer to within my main app. So I can do of that for getting a better performance. And then next thing I would like to talk thing about applications, and the question is, most of the times JPEG, as developers, we really don't care about this. I'm sure PNG, right? And generally designers really don't care about performance, so they will always say PNG because I can do a lot of creative stuff in that. I can set transparency and so on, blah blah blah. But as a developer, we say, okay, designer wants it, we'll put it here. But we don't even think that if it's a background image, do we need transparency there? Maybe, maybe not. If it's something which really doesn't require transparency, never put PNG or stick with JPEG. The compression, how the JPEG work is, the JPEG decoder is much faster than the PNG decoder, and hence the performance of an app with the same image, if there is no transparency, certainly JPEG works way better than PNG. So always go with this. Now, choosing between images versus XAML. This is again a question I get with developers, is whether if I were to show some visualization, can I just show an image or should I use a XAML for that? So the answer is, if it's just a static visual, always use an image. It's much less resource intensive because XAML for visuals requires parsing the XAML and creating an object in the visual tree, which adds to the CPU time. It takes a good amount of UI thread as well, which means if it's just a static image, kind of a requirement like static visuals, use image as much as possible. If it's something where you need interactivity, you need XAML there. A proper use case example is, a checker kind of, or a chess kind of a game, and the background of a chess game or a checker game is basically, you might want to create that on XAML. But trust me, don't do that. If you do XAML, cache it, use it. At the end of the day, it's going to be similar performance. But generally, that kind of thing, a static visualization like a chessboard, can always be better performed using a background image over there. So in those cases, you better use images to XAMLs. And another query regarding image generally comes up is, the concern comes up is the image size. Okay, caps is what I was pressing. So image size, don't cross a barrier of such as then there is no point in having just an overhead. And I had a quick sample, like in case if you really want to render a image which is above 2000 pixels, do consider loading only a part of it, and you can load those large images in a little nicer way. So in this case, you can see this sample basically loads on button click. It does that loading of an image. If I were to just load it 3000 pixel image of width and height, it doesn't make any sense to me of having a higher resolution picture and then making it lower resolution and then rendering it. You might be doing a lot of bad things over there which you probably don't want to do. But still, if the need is that you want to show part of it only, you can still do that this way. Writable bitmap, and then you can set that width over there, and using an extension you can load this zip. This would load only in the area which, it's not going to load the whole image in the viewable area, but only part of it. So but that works for people. You can have a scroller, you can scroll up, down, so on. So here when I click on this load image, basically it's going to load up, but this actual image is not the same image. So if I show you the image, this is how the image looks like. Oops, it's taking some time. Oh, that's a splash screen image. Sorry, my bad. Where did it go? Yep, test 3K. So this is the image. This is really, really, really high in terms of, it's 3000 by 3000. So what this current app is doing right now is it's loading only a small part of it. That's slightly the top rectangle which it kind of loads. So you can do that part with still so much of effort here using writable bitmap. So this is regarding the image thing. So these are some bad things which generally we find developers doing. Apart from this, in terms of media, whenever you are using media in your application, try and use the build action to content for these media items. So I'm sure you guys might be knowing it, like when you're trying to compile it, set the content for each of them. If you check out, okay, someone pinging me about Android. Cool. Forget it. So you can check out each of those items has under properties a build type as resource. You can see all those items over there. You can set them to content, and please do that for media. I'll tell you the reason behind that. If you set it to content, it gets stored as and referenced as a loose file along with this app. So there's nothing like decoding or encoding, things like that. So it just plays it. If there's a media like a video or an audio, it just takes it as a content and then plays it there within the app. Whereas if you select the same, for instance, video, as a resource item while you set the build action to resource, what happens for that video is it'll get accessed by retrieving, or basically something. You get access to it by returning a stream to that file, which is certainly a performance overhead over there, because you don't want to be doing that. So go ahead, set the build action for to content whenever you had media based stuff over there within your application. Certainly helps in making your performance better over there. So regarding media, yep, I think build action to content. That's it. Regarding objects, I probably would want to show you that as well, that sample. When you're working with XAML, and this is a common use case scenario, that when the user, for instance, when the user is signed in versus when the user is not signed in. When the user is not signed in, you probably want to hide some XAML stuff. Whereas when the user is signed in, you want to show him all those details there. Like my profile, you want to show that on the same page, details only when I'm logged in. So you want to hide those XAML items over there because you don't have any data to fetch and bind and show the user to. So you can set this visibility property, can control it through your CS files. And also how this benefits is using this visibility property, you can actually set a XAML object to be set to false, which means not visible. And if you do that, it kind of doesn't load it in the visual tree, which is good because it doesn't add to the overhead of loading that particular XAML element. So visibility property is something which you can play around with to a larger extent when you have performance issues, and you should be using visibility property. And the other thing is This is the technique used for hiding and displaying objects in XAML. You don't want to be always going or navigating to another page and so on. You want things to get visible or invisible on the same page. It's certainly of a lot of use. And the other thing is, question comes when use visibility property or use another property which is known as opacity, and you use that with a bitmap caching, which I was talking about earlier. And you can use this bitmap caching by setting cache mode property to bitmap. So I'll show you one example which basically they do this and certainly adds to a lot of performance benefit. I can actually run that here. Hiding objects. Yep, actually let me run the profiler here as well. I think I'm running a little short of time, so let me quickly run through this. Okay, app analysis, and I'm gonna do this app analysis. Let me start this one. So as I said, hiding objects, it kind of hides those objects. It's running a session where I don't know. Okay, right here. So you can see opacity property set to 0% right now. Cache is set to on. That is good. I can select on collapse. Basically, collapse is when you set that visibility property to be false, is basically this button collapse for. So when I click on collapse, it sets the visibility property of those rectangles. I can tell you the numbers. It's 115 numbers in the background, which are set to false now, and you can see none of them visible on the same page, right? So imagine this was the scenario which you had in your application. When you log in, you want to show some different visuals in the background. You want to pull up user profiles, base data, and show up on the background image or something like that. You can do all those shit here. And then the other thing is the caching, right? I can switch on the cache right now. Certainly the visual tree is going to be very, very less. It's going to be awesome right now. But when I set this to this, you can see actually the movement of those squares are kind of, you can make out the frames per second is going to go less here, and it's kind of intensive right now. Also, if I switch off caching, it cache it to off, so it's not caching anything. Actually, the performance improved right now. When I set the opacity value to 100%, you can see it does the same stuff what my visibility property does, but it I would say, again, as per use cases, you should be able to figure out which one is better to be used, visibility property or opacity with caching. So whichever works better for you. So if I now go ahead and make this as visible, doesn't work because now my opacity property is already set to 100%. So let me just do this, right? I can collapse it. Performance becomes better once I visible, caching, when I set it to off again, it's performing better. So now I can stop this whole thing, and it's going to create a report, and I can actually go through those reports to check out my memory footprints across whenever I enabled or disabled each of those items, to actually figure out which is the ideal use case scenario which I should use in my application in such scenarios. So that was one thing before I actually end this talk. There were things like, okay, we talked about hiding and unhiding XAML. Then let's talk about displaying lists. Again, very important. Suggested approach is try and use long list selector. I know people with Windows onwards, they will always use this. Phone 7 apps probably should use this, and instead of using your older control or just a list box or something of those kinds. So use long list selector. That's a suggested control, gives you a lot of performance benefits over there. And rather than making at times with one of these apps which I saw, is they made a lot of requests for small amount of data. So a lot of REST based calls which happened during the whole app running stage, which was bad because that helps a lot in killing your phone's battery. Because how generally it works is, rather than having to get these small amount of service calls happening in serial order, you should do that parallelly. Use async as much as possible, and then try and make all these calls parallelly, and get the data done. And because how the phones work is basically to optimize the battery, the device might turn off radio after a pre-configured time, and if that happens, you probably don't want to be running your application right then. So that was one thing. So making large requests, and then app startup. First impression is the best impression, right? So you should use splash screen, and if you require, you can some scenarios where someone wanted a nice looking change or animation on the splash screen. And if you ask me how do you draw an animation on a splash screen, probably I don't know, or probably you might not find a direct way of doing that, but you can still do that. You can extend the splash screen, you can override the on navigated to method, and you can do all those kind of crazy stuff there. You can have an extended splash screen, and unless that loads or you can't, you probably will not go into the control initialization states or whatever. You can do overriding over there. So you can have the extension of the app startup screen as well if the performance is still bad. So that's one thing. Another thing is break the app into smaller assemblies. I think splitting of app resources, we talked about that. Yeah, so smaller assemblies, that's the one. Okay, and then also one of the apps we figured out, they were doing a lot of crazy stuff, custom controls, and they were doing validation checks and blah blah whatnot on the initialize method as well, and which caused a lot of performance issues. So be careful not do a web service call or a REST-based API call in such scenarios unless it's really needed. So just get rid of those. So yeah, I think these are some of those bullet points. I couldn't create a slide with nice looking images. So something which you should keep in mind, this comes with when you actually screw up some apps. So I have those experience with me, thought of adding those. So these are some of those things, plus the tool which kind of helps me in figuring out these issues, and then I'm trying to tell you out these issues to how to solve it. So I think I'm done with this. Maybe we can have another session focusing on 8.1 XAML apps, because the tool is slightly different over there, and I would say it's kind of advanced as well. So that can be another session for XAML or the Windows runtime apps. Cool then. Thanks a lot. Any Q&As? Just let me know.
Yes, Abhishek. Thanks for the session. So there are a couple of questions from Shahrukh. So
Yep.
can you please take it up?
Oh my God, Shah Rukh Khan.
So the first question is there any solution to minimize the app to zero state?
Zap to what?
I mean, the first question was, is there any solution to minimize the app resume state?
Okay, app resume state. So again, that is dependent on a specific, use cases of that particular app. But to reduce that, if you're, what I could say is that if your memory footprint of that app is less, the faster it responds back in terms of resuming it. So nothing really like in terms of best practices. If you have visuals of 50 MB to load, you still will load that. So nothing like it can help you better. But I think Windows Phone 8.1 has a different app lifecycle model. It comes from Windows runtime, and it kind of, as I said, it lets you do dynamic memory, not lets you, but the operating system do a dynamic memory allocation, which can keep a lot of apps there in the background without tombstoning it, which means that the app resume automatically will be faster on a Windows 8.1. As a developer, you don't have to really do anything there.
Okay, so the other question from the same person is mention some mostly NuGet packages which are mostly used. I think this question is about what are the generic NuGet packages that have been used when developing Windows Phone application.
Mhm. Okay, cool. So I think for that, Karthik, you're the right guy, yaar.
I mean, basically it depends on the requirements we do. So it's not like we put on all the NuGet packages and make a very
Correct.
big build of our app.
Yeah.
So
Yeah.
if
So
there
I
is no
think you can pick
question,
it up from the gallery,
yeah,
whichever required.
that's right. I think there are no more questions. Okay, thanks Abhishek for the wonderful session on the performance analysis and the consideration. I think the guys would enjoy the session. And for the viewers, if you want to watch the recorded session, you can definitely go back to youtube.com/b.net TV, where we have all the recorded sessions about the B.net webinar. I mean, the Wednesday Hangouts has been posted over there. So our next B.net Hangout will be on 2nd July. So you guys can stay tuned for the updates in our B.net Facebook page. So, Abhishek, there is one more question from Teshasvi.
Okay. Can we use .NET uh, native to compile to native instead of CIL, MDIL? No, I'm not sure. I don't see anything officially being there. I'm not sure. I'll have to check there, but I don't think there is any way. Are you aware of anything like that, Karthik?
No, even I'm not sure of that. Maybe we can check. So whatever, I mean, you can just post this question on to our B.net group so that we'll pitch in and we'll let you know
Yeah,
once we get some idea on that.
yeah.
So I
But
think,
also put the point there. Why would we actually need that?
yeah, that's right.
Yeah. So I mean, what would the use case be to compile it native, because that already gets taken care of as a native image when we install that.
Exactly. Okay, so if there is no questions, let's wind up this. Thanks for, I mean, once more, Abhishek, for the wonderful session. So,
Yeah.
have a good day.
Yeah.
Good night, guys.
Thank you guys. Bye bye.
Bye.